Hello, everyone. My name is Raka Ray, and I have the privilege of being the Dean of the Social Sciences here at Berkeley. And on behalf of the leadership, the students, and the faculty of Berkeley Psychology, it gives me great pleasure to welcome you here today, you all alumni and friends. Today is a special day, and we are delighted to be celebrating with you. Thank you for coming together in support of Berkeley Psychology's 100th birthday. You have all added to the century-long legacy of impact, cutting-edge research, and preparation of students who are ready to go out into the world to make a difference like so many of you did. And all of this has made Berkeley Psychology the #1 department in the world. Today is an opportunity to reflect on and celebrate our past while looking ahead to a bright, bright future. Let me also formally welcome you to Berkeley Way West, your home on the UC Berkeley campus. Opened in 2018 under the direction of former department chair Anne Kring. Anne, where are you? Anne Kring. Berkeley Way West provides the collaborative workspace and lab environment our students require. It also is home to the psychology clinic, classrooms, and as you can see here, beautiful space for building community. Our program this evening will feature examples of the transformational work being done in our department, and there'll be time for questions, and we'll also have 2 unique demonstrations. To introduce our program then, let me welcome the department chair and Professor Serena Chen, and I will look forward to speaking with you all again at the end of this program and to hearing your own reflections about your time here as well as about the program. Thank you again, and please join me in welcoming Professor Chen.
Thank you so much, Raka, for being here tonight, for those introductory remarks, and for your support of our department and this event. We are so excited to have you all here today. We have been celebrating our 100th year all year, because it's a whole year. But this is our first in-person event, so it's really exciting to be able to do that and to see so many faces here with us today. So we're proud of this building. And if you're interested in learning more about the building, for example, touring the psychology clinic, our laboratory space, and so forth, there is a sign-up sheet by the reception desk. Just sign up and we'll follow up with you afterward if you're interested in seeing more. So we do, as Raka said, we have a wonderful program today. 3 of our faculty are going to tell you about their work, and then we're going to have 2 demonstrations showing you some of the tools that we use to do our research. And you'll see a surprise guest in our last demonstration, but I'll just leave it at that. So without further ado, let me introduce our first faculty speaker, and that is Professor Celeste Kidd. She's an assistant professor in our department, and she studies kids, and so she runs the Kidd Lab, and she's going to talk to you today about how to know. Yeah.
Okay. Whoop. Mic's okay? You guys can hear me okay? Okay, great. In my lab, we are very interested in belief formation. We want to understand how we know the things that we know. We live in an age of unprecedented access to information, but misinformation is ubiquitous. What I'm going to talk about today is how people's access to truth is not limited so much by what information or how much information is out there. The limiting factor on how much you can know, how close people can get to truth, is really governed by the cognitive systems that they possess that guide their learning. I want us to start by taking a moment to appreciate that there's far more information in the world than anyone could hope to learn. That simple fact has very profound implications. It means that to be a person in the world, you have to pick and choose. You're going to be forming beliefs based on a very small subset of all the information that is theoretically available to you. And you're going to be making 100,000 micro decisions every day about where to look, what to click, what to explore, and what to watch. How you make those decisions is highly informed by what you already know, what you believe to be true, and where you expect to have uncertainty. This is going to be a spoiler to no one, but it is not a perfect system. Our cognitive systems have evolved to handle information overload, and one of the tools that it uses to do that is boredom. For example, our systems engage boredom when we're confident that we have learned everything that there is to know. These systems prevent us from hyperfixating, but they do so at a cost, and that cost is sometimes shutting down the information tap before we have actually gotten the right idea. My lab started down this road initially thinking about these questions from the perspective of cognitive development. Kids have to go from knowing very little about the world to eventually possessing relatively sophisticated networks of knowledge about how things work. My lab has made progress on understanding these processes in part by employing a combination of computational methods and human data, mostly from behavioral psychology experiments. Using, for example, screen-based eye trackers, which allow us to give human infants the ability to control what they see. This allows us to directly measure how infants solve the sampling problem, how they're weighing information gain against opportunity cost. We also use head-mounted eye trackers like this one. This allows us to capture both what the infant has visual access to moment to moment, and then also where they're choosing to look in the scene. So that little purple spot right there shows where the infant wearing the eye tracker is fixating. You see a lot of looks to faces. That's us. We just got it working. We were very excited. And a lot of looks to the toys. For this work, we often look at human infants because it's much more straightforward to get a raw measure of what they're interested in looking in. It's actually surprisingly hard to get adults to do that. They get really paranoid if you say just like, look at whatever you want. But the point I want to make here is even that when we are testing babies, this work is not just about babies. Studies with human infants help us understand how we come to know what we know about the world as humans in general. The lab uses this work to help us understand how we should design systems that interact with humans in order to give them the best possible shot at building mental models that accurately reflect reality. Beliefs form over time, starting in infancy but continuing throughout your whole life. And with my remaining time, I'm going to highlight just 3 things I think that we know about how those cognitive mechanisms limit your access to what's true. And I'll go ahead and launch into that. Number 1, the first thing that I think you should know is that beliefs guide interests. We are built to form probabilistic expectations about the world around us. We're doing it constantly. And in doing this, we're looking for things that offer us learning value. We're looking for things that violate our expectations, but just a little bit. For example, in this series of experiments, we showed babies displays that we designed to elicit probabilistic expectations. So in these displays, there's objects popping out of boxes in some order like this. Some of the events end up being more predictable. Some of them end up being more surprising. And infants are able to control the displays on screen-based eye trackers moment to moment. As long as the infant is continuing to watch, the display continues to unfold. So the objects continue to pop out of the box. If they look away, then it ends. Oops, she almost looked away, but then she didn't. If you watch this for a minute, you might notice she's like enjoying some of the items more than others. That was very exciting. And we keep showing her this sequence until she looks away for 1 second. So she looks away, it turns off. We get the attention getter back, which is a laughing baby. Babies love laughing babies, which is really funny because they probably don't know that they themselves are babies. So they're just like liking them for the same reason we like babies. They're like, you're so cute. She resets and then we do that over and over again. Okay, so that's our behavioral data. To analyze it, we construct a Bayesian statistical model that just represents a formal theory of how infants might form uncertainty about what would happen next. This model allows us to test how uncertainty guides infant attention or doesn't. I was like, that's a possible outcome in a simple and independent way. How we do that is we plot the model's estimate of how much uncertainty an event contains against infants' actual look-away behavior. And when we do that, we get this, what we described as a Goldilocks effect, by which I mean that infants tend to look away at events that are very predictable. You see like a higher look-away probability on that side. And they're also likely to look away from events that are highly surprising. So that low bit of the U means that's where they're most engaged. They're least likely to look away then. This U-shaped Goldilocks preference pattern applies not just at the group level, it's also at the level of individual infants. It's at older ages, regardless of individual differences in things like self-control. And it's even in rhesus macaques. Thus, this is not a human-specific behavior. We think it represents a robust feature of intelligent attentional systems very broadly. This pattern reflects, thus, an elegant organizing principle that allows an agent to continue to build on existing mental representations as they grow and change. I was like, as you observe more stuff, your expectations update, and you're always seeking stuff that surprises you a little. Importantly here, and this is also my second point, is this left part of the U. Certainty, when you are certain, that diminishes interest. Our system accommodates that we have limited time, attention, and processing capacity, and it focuses on learning material about which we are moderately uncertain. This, however, although sensible, introduces a hitch in the system. It's what we think that we know that determines our curiosity. It's not what we actually don't know. So if a learner thinks that they know the answer to a trivia question, they are not curious to check the answer, so they don't, and they just get stuck with the wrong answer. We think that this can help explain why people sometimes get stuck with stubborn beliefs that aren't justified given evidence that exists in the world. Once a person becomes certain, they don't consider subsequent evidence in the same way, and they don't update, they stop learning. So the next question is, where does human certainty come from? And that's my third and final point. Certainty is driven by feedback, and I'll give you an example of what I mean. In this study, we had people learn a novel rule-based concept like daxiness. The participant's job here is to figure out what daxiness entails just by seeing examples and then guessing whether or not they are daxy. The concept could be something very simple, so it could just mean red, or it could be something much more complex that requires the learner to track multiple different dimensions like the color, the shape, and the size. This setup allows us to evaluate different theories of where people's certainty comes from. And what we find when we do this is that the best predictor of learner certainty is recent feedback. If you get a string of correct responses just by chance, you become certain that you have the right idea, even if you should not, and you stop learning. If subsequent evidence you might expect would cause somebody to update, once you become certain, you don't count that the same way. That's very striking, especially in this context where you're being asked, is it DAXY? You have to say yes, no. It's a 50-50. It's very easy to get a string of correct responses just by chance without actually understanding the concept. So I walked you through some of what we learned about how beliefs are formed. Beliefs guide interest. Certainty diminishes interest. Certainty is driven by feedback. What I want to end on by highlighting is a couple of ongoing efforts that apply what we've learned towards trying to design interventions and systems that give people better access to truth. Given what I've said about feedback driving certainty, it's maybe clear how this could potentially be problematic in the context of relatively new changes in how people seek out information and how they seek out answers. Online platforms like search engines and social media generally are offering content on the basis of engagement. And engagement is known to be highest for content which would be interesting if it were true, not content that is judged to be accurate. That's a very different thing. So for this reason and other factors, when people go online to do their own research, there's a real risk of them seeing a block of consolidated feedback of the type that could push them from unsure towards certain very quickly. This is a screenshot from a study in which we had people look at the results from a relatively neutral web search, activated charcoal. Activated charcoal, in case you don't know, is a mostly pseudoscientific wellness fad, but searches for that term generally yield results that suggest that activated charcoal is just like wonderful for your health. This is just a few clicks. Within a few clicks, people go from entirely unsure whether or not it's good for wellness to believing that, yeah, it probably is. This red bar represents someone who has watched just 3 or so 2 to 3 minute videos. So we ran this. It's a little bit distressing. And for a while, the lab tried to develop interventions to reinduce uncertainty in the face of unjustified certainty. And when we did that, we weren't very successful because certain beliefs, it turns out, are really quite stubborn. However, we've since identified several promising interventions that, rather than trying to bring back uncertainty when it's gone, encourage people to slow down and become certain less quickly in the first place. So I'll end by mentioning just 2 of those efforts. This recent paper shows how sensitive people are to social information. This plot is showing that people evaluate a belief to be more likely if they believe that that belief is commonly held by others. So giving them social information about a belief being commonly held can help guide them towards truth. This is, of course, a bit of a double-edged sword. It can be used for evil too, but it means that groupthink could be used and leveraged to promote truth. And that's something that we're working on now. A second promising direction that we're working on involves attending to the context in which learning is happening. In this study with young kids, they learned from 1 of 2 different types of textbooks, either reliable ones that I hope are kind of traditional textbooks or full of flawless information, or they learned from a less conventional source, which is textbooks that were unreliable and contained obvious detectable errors. While this might sound counterintuitive at first, flawed learning material can be helpful in some cases. This plot is showing that kids who saw unreliable textbooks spent more time checking new claims. So experience with nonsense can actually promote healthy skepticism. You might expect that what you should do if you're trying to bring up like smart, healthily skeptical kids is like give them just good material, but maybe that's not right. We have some systems in place to help us deal with this. Right. We're not at all done. So this work is just starting, and I hope I've convinced you that it's important. I want to close by thanking everyone in the lab who contributes to this work every day. 2 of them are here right now and will help with the demos. I also want to thank the funders, the organizers of the event. Thank you, Christian and Anya. And all of you for coming here to help psychology celebrate 100 years of psychology research. Thank you very much.
Thank you so much, Celeste. Okay, we have about 8 to 10 minutes where Celeste can take questions if anybody's interested. Just go ahead and raise your hand, and we have people with mics around. Or you don't have to use the mic. Yeah. Yeah, Art. Yeah, right behind you. Yeah.
Oh, okay. Thank you. Does any of this different if the information is a threat versus an opportunity?
If it's a threat versus an opportunity,
Yeah.
Can you say a little bit more about what you mean?
Well, if you're getting information about whether there's a tiger outside versus whether there's a chance to get some wonderful new toys or some new.
Yeah. Yeah, so I was like, that's a very interesting question. So there's a whole literature on how difficult it is to adopt a belief that goes against, like, is in conflict with other beliefs that you hold very strongly or that are part of your identity. There's that. But then what you're talking about when it's like under pressure, there's also known effects of cognitive load making decision-making difference. You'd expect that the belief should be formed more quickly and thus on like a more sparse sample. We don't have anything in the lab that directly speaks to that, but I will say that we have an undergraduate that's very talented in the lab that's working on a series of experiments testing whether when people are under cognitive load, when there's something like time pressure, or when your attention is spread thin, whether that might lead to faster rates of polarization because of the sparse sampling issue. So I would expect for it to be different, whether it's a tiger or it's like a threat to your political identity probably makes a difference. It's like those are probably two different circumstances.
Just as an example.
Just as an example.
Yeah.
Thanksgiving is coming up, so I was like, I know we're all thinking of that.
Yeah. Other questions, comments? Yep, back there.
Only because we just had the midterm elections, within the context of, and I have to admit, I watch Fox from time to time, besides CNN and PBS. But I mean, the realities are so different from the same set of events.
Right.
And it is disturbing. Do you see any laboratory experiments or something that you could do to try to do something that's going to sort of start to break down those barriers?
Yeah, so this did not fit in the 12-minute talk, but we do have a body of work looking at the prevalence of misinformed beliefs. That's a term that we're using to capture sort of all beliefs for which there's other evidence that suggests that that belief is not right. This is pseudoscience and folk science and other conspiratorial beliefs. So it's like we kind of lump those all together. We were interested in whether there are any demographic predictors of the prevalence of these kind of beliefs, and we'd never seen anybody do a survey of just like a lot of people. So we did just a massive survey of like 1,000 people and collected demographic information and also just asked them about like every misinformed belief that we could find. So things like belief in particular alien sightings for which there was not evidence, or as a JFK assassination things, 9/11 conspiracies, anti-vax conspiracies. And what we were wondering is whether or not you might see there being a problem of some people being more gullible. This is a common perception, is that like the misinformation is being spread by like a few people that are just more gullible, and if you could just like inoculate them and make them stop doing that, like the whole society would be better. What we found is going to sound disturbing at first, but I have a good part. Like it gets better. Everybody has several misinformed beliefs. All of us believe something that is not based in reality, for which there is evidence that we should really update. However, while we all hold misinformed beliefs, and we did not find any evidence of political affiliation, the media that you're consuming, where you live, the age you are, as like everybody had different ones, but everybody had them. But although they were common in the population as a whole, when you look at all of them, they were thinly held. So like everybody is trying their best probably and getting a few things wrong. There's one exception, which is people that believed anti-vax conspiracies did clump together and pattern differently. Yeah, it looks like most people are like much better and generally coming to the right conclusion. I think the media sort of distorts because you put on stuff that's sensational. So we all have a sense that misinformed beliefs are like more strongly held than they are because those are the examples we see. If somebody holds a misinformed belief, but they hold it with low certainty, that's great, because that's going to bias them to when they hear new information about it, they're going to attend to it. That's actually exactly what you want. What you want to prevent is misinformed beliefs that are held with high certainty, and that doesn't happen very often. So,
great. Maybe one more question we have time for?
Seems like your research dovetails.
Yeah, so you know what? We haven't gotten into that, but we are starting to now. We're interested in whether you can do something to promote intellectual humility, and we're starting to experiment. It didn't work with adults. I was like, we're starting to experiment with whether or not teaching people about their own fallibility and then introducing the scientific method as a solution for that could make people generally more intellectually humble. And yeah, I don't know if it's going to work, but I'm optimistic. A lot of us are scientists. I hope that's what we're doing when we train students. I think it's effective. So I was like, we haven't found a quick version of it, but yeah, I think that those avenues have a lot of promise too.
Okay, thank you so much, Celeste. You'll be sticking around, so Celeste will be around. You'll see her again in the program. Okay, we're going to move to our second speaker, Matt Walker, who's a professor of psychology and neuroscience, and he directs the Center for Human Sleep research here. I'm dropping everything.
I have that effect on most.
I know, you're just like, I'm so nervous. Anyway, Matt's going to talk about why sleep, why we should sleep. Okay, thanks, Matt. Yeah.
Thank you very much. And I think we'll just switch over the slides if we can. Wonderful. So it's a privilege and a delight to be speaking with you this evening. I would like to start with the standard disclaimer, though. I think it's safe to say that when most speakers look to their audience and see people who are falling asleep or nodding off, it's profoundly disheartening. However, based on the topic of this presentation, I'm going to actively encourage that kind of behavior from you, okay? In fact, knowing what I know, particularly about the relationship between sleep and memory, it's the greatest form of flattery for me to see people like you not being able to resist the urge to strengthen and consolidate what I'm telling you by falling asleep. So feel free just to sort of ebb and flow in and out of consciousness throughout the entire presentation. I'll take absolutely no offense. And here tonight, I want to tell you both about the effects of sleep on your brain and also on your body. Let me start with the brain and the functions of learning and memory. Because what we've discovered over the past 10 or 15 years is that you need sleep after learning to essentially hit the save button on those new memories so that you don't forget. So in that way, sleep is going to future-proof that information within your brain. But recently we've learned that you not only need sleep after learning, you also need sleep before learning. But now to prepare your brain, almost like a dry sponge, ready to initially soak up new information. And without sleep, the memory circuits of the brain essentially become waterlogged, as it were, and you can't absorb new information. Let me show you the data. So here in this study, we decided to test the hypothesis that pulling the all-nighter was a good idea. How did we do that? We took a group of perfectly healthy individuals and we assigned them to one of two experimental groups, a sleep group and a sleep deprivation group. Now, the sleep group, they're going to get a full 8 hours of slumber, but the deprivation group, we're going to keep them awake here at the sleep center under full supervision. And there's no caffeine, there's no naps, miserable for everyone. And then the next day, we're going to place those participants inside an MRI scanner. And we're going to take snapshots of brain activity as we try and have them learn a whole list of new facts and information. And then we're going to test them to see how effective that learning has been. And that's what you're looking at here on the vertical axis, the efficiency of learning. So the higher up you are, the better you are. And what we find is that under conditions of sleep deprivation, there is a quite profound 40% deficit in the ability of your brain to make new memories without sleep. And I think it should be concerning, especially considering what we know is happening to sleep in our education populations. Just to put this in context, it would be the difference between acing an exam and failing it miserably, 40%. And we've gone on to discover exactly what goes wrong within your brain to produce these types of learning disabilities. There's a structure that sits deep within your brain called the hippocampus. And you can see it here in these orange-yellow colors. Think of the hippocampus almost like the informational inbox of your brain. It's very good at receiving new memory files and then holding on to them. And when we looked at this structure in those people who'd had a full night of sleep here in green, what we saw was lots of healthy learning-related activity. Yet in those people who were sleep deprived, we actually couldn't find any significant signal whatsoever. So it's almost as though sleep deprivation will shut down your memory inbox, and any new incoming files are just being bounced. You can't effectively commit new experiences to memory. And if you'd like to know, parenthetically, what life is like without a functioning hippocampus, just watch the movie Memento. I suspect some of you have seen it. It's a great movie. I won't spoil the punchline if you haven't seen it. But this gentleman suffers brain damage. And from that point forward, he can no longer make any new memories. He's what we call densely amnesic. The part of his brain that was damaged was the hippocampus. And it is the very same structure that sleep deprivation will attack and block your brain's capacity for new learning. So that's the bad that happens if I take sleep away from you. But what about the good that happens when I give sleep back to you? What is it about the physiological quality of your sleep when you do get it that restores and enhances your learning and memory ability each and every day? Well, let's come back to that control group here for a second. Remember those folks in green that got a full 8 hours of sleep? Well, we can answer that question. And by placing electrodes all over their head, again here at the sleep center, what we were able to discover is that there are big, powerful brain waves that happen during the very deepest stages of sleep that have riding on top of them these spectacular bursts of electrical activity called sleep spindles. And it's the combined quality of these deep sleep brain waves that acts like a file transfer mechanism at night, shifting memories from a short-term vulnerable reservoir to a more permanent long-term storage site within the brain and protecting them, making them safe. And it's important that we understand what mechanistically is transacting these memory benefits, because there are real societal and medical health implications. And let me tell you about one area that we've moved this work out into, which is the context of aging and dementia. Because of course, it's no secret that as we start to get older, our cognitive abilities begin to fade and decline. But what we've also known is that a physiological signature of aging is that your sleep gets worse. And not just any type of sleep, especially that deep quality of sleep that I was just discussing. And only last year, we finally published evidence that these two things, they're not simply co-occurring, they are significantly interrelated. And it suggests that the disruption of deep sleep is an underappreciated factor that is contributing to what we call cognitive decline in aging, and most recently we've discovered in Alzheimer's disease as well. Now, I understand this is remarkably depressing news. It's in the mail, it's coming at you, but there's a possible silver lining. Unlike many of the other factors that are associated with brain aging and dementia, for example, changes in the physical structure of the brain, even changes in the blood flow dynamics of the brain, those are fiendishly difficult to treat. Medicine doesn't have any good wholesale approaches right now. But that sleep is a missing piece in the explanatory puzzle of aging and Alzheimer's is exciting because we may be able to do something about it. And one way that we're approaching this here at the Sleep Center is not by using sleeping pills, by the way. Unfortunately, they are blunt instruments that do not produce naturalistic sleep, and I'm happy to speak about those during Q&A. Instead, we're developing a method based on this. It's called direct current brain stimulation. It sounds like the stuff of science fiction, but it's science fact. You apply electrode pads to the head, and then I insert a small amount of voltage into your brain. And it's so small that you typically don't feel it, but it has a measurable impact. Now, if I apply this as stimulation during sleep in young, healthy adults, as if I'm singing in time with those deep sleep brainwaves, not only can we amplify the size of those deep sleep brainwaves, but in doing so, we can almost double the amount of memory benefit that you get from sleep. So the question now is whether we can translate the same affordable, potentially portable piece of technology into older adults and those with dementia. Can we restore back some healthy quality of deep sleep? And in doing so, can we salvage aspects of their learning and memory ability? That's one of our hopes now at the Sleep Center. So that's sleep for learning and memory, aging, dementia. That's sleep as an example for your brain. But of course, sleep is just as essential for your body. And here I could have gone into any one of the model systems. I could tell you about sleep and your metabolic system, that after 1 week of short sleep, your blood sugar levels are so disrupted that your doctor would classify you as being pre-diabetic. Or I could tell you about men who are sleeping just 5 hours a night. They will have a level of testosterone which is that of someone 10 years their senior. So a lack of sleep will age a man by a decade in terms of that critical aspect of wellness and virility. And we see equivalent impairments, by the way, in female reproductive health. We see that in estrogen, luteinizing hormone, and follicle stimulating hormone. Or I could tell you about sleep loss and your cardiovascular system, and that all it takes is 1 hour. Because there's a global experiment performed on 1.6 billion people across 75 countries twice a year. It's called daylight savings time. Now, in the spring, when we lose 1 hour of sleep, what we observe is a subsequent 24% increase in relative heart attack risk the next day. Isn't that stunning? And you see exactly the same reverse profile in the fall, in the autumn. When we've just switched now, there is a 21% reduction in heart attacks. It's bidirectional. And many of us think nothing about losing just 1 hour of sleep. By the way, you see exactly the same profile for road traffic accidents on our streets, even suicide rates. But here, as a deeper dive, I want to focus on this, sleep loss in your immune system. And I'll introduce these delightful blue elements in the image. They are called natural killer cells. And you can think of natural killer cells almost like the Secret Service agents of your immune system. They are very good at identifying dangerous, unwanted elements and eliminating them. And what they're doing here is embedding themselves into a malignant cancerous tumor mass and destroying it. So what you wish for is a virile set of these immune assassins at all times. And sadly, that's exactly what you don't have if you're not sleeping enough. So here in this study, we won't deprive you of sleep for an entire night. We'll simply limit your sleep to just 4 hours for one single night. And then we'll look to see what's the percent reduction in immune cell activity that you suffer. And it's not small. It's not 10%. It's not 30%. There was a 70% drop in natural killer cell activity. That is quite a concerning state of immune deficiency. And it happens quickly after one short night of sleep. Imagine the state of your immune system after weeks, if not years, of insufficient sleep. And it should come as no surprise to learn that we now have significant links between a lack of sleep and numerous forms of cancer. In fact, that link between a lack of sleep and cancer is now so strong that recently the World Health Organization decided to classify any form of nighttime shift work as a probable carcinogen. In other words, jobs that can induce cancer because of a disruption of your sleep-wake rhythm. So you may have heard of that old maxim, you can sleep when you're dead. Well, I'm being quite serious now. It is mortally unwise advice. Because if you adopt that mindset, we know from the data you will be both dead sooner, and the quality of that now shorter life will be significantly worse. This is what epidemiological studies teach us. The shorter your sleep, the shorter your life. Short sleep predicts all-cause mortality. And if increasing your risk for the development of cancer or even Alzheimer's disease were not sufficiently disquieting, we have since discovered that a lack of sleep will even erode the very fabric of biological life itself, your DNA genetic code. So here in this study, they took a group of perfectly healthy individuals and they limited them to 6 hours of sleep for 1 week. 6 hours of sleep a night for 1 week, I should say. And then they measured the change in their gene activity profile relative to those same individuals when they were getting a full 8 hours of sleep. And there were two key findings. The first was that a sizable and significant 711 genes were distorted in their activity caused by a lack of sleep. And we know this is relevant, by the way. We know that almost 1 out of every 2 people that you pass on the street is trying to survive on 6 hours of sleep or less during the week. The second result was that about half of those genes were actually increased in their activity. The other half were decreased. Now, those genes that were decreased in their activity, or what we call underexpressed or switched off, were genes associated with your immune system. So once again, you can see that immune deficiency playing out, but now at a genetic level. Those genes that were increased, or what we call overexpressed, triggered by that lack of sleep, were genes that were associated with the promotion of tumors, genes that were associated with long-term chronic inflammation within the body, and genes that were associated with biological stress, and as a consequence, cardiovascular disease. There is no aspect of your wellness that can retreat at the sign of sleep deprivation and get away unscathed, it seems. Sleep loss is a little bit like a broken water pipe in your home. It will leak down into every nook and cranny of your physiology and even tamper with the very DNA nucleic alphabet that spells out your daily health narrative. And at this point, you may be thinking, oh my goodness, okay, I get it. How do I start to try and get better sleep? What are your tips for better sleep? Well, here I could give you at least 2 better tips for better sleep. The first is regularity. Go to bed at the same time and wake up at the same time. No matter whether it's the weekday or the weekend, regularity is king, and it will anchor your sleep and improve the quantity and the quality of that sleep. The second tip is keep it cool. Your brain and your body need to drop their core temperature by about 1 degree Celsius or about 2 to 3 degrees Fahrenheit in order for you to fall asleep and then stay asleep. This is the reason that you will always find it easier to fall asleep in a room that's too cold than too hot. Because the room that's too cold is at least taking you in the right temperature direction for good sleep. So aim for a bedroom temperature of around about 67 degrees Fahrenheit. I know it sounds cold. And women tend to run colder than men. It's totally fine to have a hot water bottle at the end of your bed, wear thick socks, but cold the ambient must be. So in closing, what is the blueprint manifesto that I would like to offer you? Well, I think it would simply be this. Sleep, unfortunately, is not an optional lifestyle luxury. It is a non-negotiable biological necessity. Sleep is your life support system, and it is Mother Nature's best effort yet at immortality. And the decimation of sleep throughout industrialized nations is having a catastrophic impact on our health, our wellness, even the safety and the education of our children. It's a silent sleep loss epidemic. I believe it is time for us to reclaim our right to a full night of sleep, and without embarrassment or that terrible stigma of laziness. And in doing so, we can be reunited with the most powerful elixir of life, the Swiss Army knife of health, as it were. And with that, I will simply say good night, good luck, and above all, I do hope you sleep well. Thank you very much indeed.
Thank you, Matt. I know many of us want to leave right now, so you can go to sleep. I'm going to show my children a recording of this because I tell them till I'm blue in the face how important sleep is, and they don't believe me.
Send me your address. There's an intervention coming tonight.
Goodness, teenagers do not understand regularity. Okay, questions. Veer, we have a few minutes for them. Yeah.
Segue to teenagers. Okay, so I'm a fan. Sleep is now my friend. But for me, my sleep is now fantastic, and 2 things had to happen. One is I was going through all the sleep hygiene steps.
Great.
With the internal emotional tone of a mean governess. No, screen's off. No, you can't watch that. No, that's too late to eat. It was like that. And so and this is frightening and inspiring, but if I did it, as long as I was doing it with this like tension and like you got to do it, or the way parents do it, to listening to adolescents talk about, oh no, my mom went to another sleep lecture and so she's in here yelling at me, where the teens would say, don't come in at midnight with a lecture or research, come in with a snack, because that's not the time you're going to fix it, right? So I just wish, so for me, the shift was, when I realized that I was not taking these steps of sleep hygiene with love, I became very intellectually humble. Like, it shook me. And I thought, oh, like, I need to be crafting this not from out of panic or fear, but I need to be crafting my routine with love. Like, what's my nighttime routine? When I had kids, they had a lovely nighttime routine. Would this fit? And so to take this, I just worry that people hear this research and they're so scared that they start taking these steps. And for me, it didn't work until I softened and then really reclaimed it. I liked your language as a diplomat, to reclaim it, but reclaim it with a sense of, okay, I'm gonna take this on. It's not just one night. It's not one yelling at your kids to go to sleep. That's going to cost you time, but how to introduce some self-compassion and self-care and some kind of badassness of, like, I'm going to sleep. So I think that there's work to be done in the how people can take this frightening, useful, amazing information and apply it in a successful way. Because for me, it was only until I realized, oh, I'm applying this like I'm going to war with myself.
No, it's a very good point, and I think, there's, how do you try to coalesce society and reunite them with the sleep that it's so desperately bereft of? And I think one way you can do it is the stick, one way you can do it is the carrot, and different people, I've discovered, respond in different ways. I think there is a sort of a loving compassion version of that can happen, and I certainly enunciate that at times too. I think what's difficult, though, is that there is an attitude in society, particularly in the professional world, of this sleep machismo sense that, people will wear their badge of honor of sleep deprivation on their arm. And I think we need to sort of try to help people understand that. And there's lots of different ways that you can do that. And speaking about smaller testicular size, if you're in a group, sometimes in these businesses that I go and speak to, you start with that fact. So I think there's lots of different ways to communicate the science of sleep. And I love the idea that you embraced a more compassionate way of doing that, which is that it's a gift. I think part of the problem is that society sees sleep as a nuisance, not a necessity. We see sleep as a cost, not an investment. And we've got to try and change some of that. So thank you.
We have time for, I know there are a lot of questions. Matt's going to hang around, but let's go ahead. We have
Serena, we have a question right here. Sorry.
Okay, where are you?
Yes, over there. Yeah.
Okay.
Hi.
Hi.
If you had unlimited funding were no object, money was no object, what problems related to sleep or detected within sleep, like what would you try to solve for with your research?
So there are scientific questions and then there are societal questions. One of the first ones that I would do is go after the societal problem itself. And that societal problem has to be solved at multiple different levels. There is no one silver bullet to solve the global sleep loss epidemic. I would start at a government level. I don't know any first world nation that has had a public health campaign regarding sleep. You have them out there for drunk driving. You have them out there for drugs, safe sex. Where is the public campaign regarding any major country for sleep? It's not present. I would like to start there. Next, I would step it down into professions. So medicine is a great example. There you have residents who are working 30 or 40-hour shifts. We lobbied that group to reduce them down. There's amazing data to say it's an idiotic practice. Every time I went into the medical board for the American Association, they said, basically, my mind's made up. Don't convince me. Stop trying to convince me with the data. And when I went back and realized, stop appealing on the grounds of compassion, but go back to them on the grounds of how much it costs them in cases, liably, legally, then all of a sudden they listened and we got the resident hours changed. But we only got them changed for the first year of residency. Why? Because that's all, we only had data from first year residents. Really? So there's something special about when you transition from year 1 to year 2 that makes you resilient to the lack of sleep. Excellent. So I would go after professions there. Next one, I would go down to education. You know, I remember when I was at school, I had those lectures on the dangers of drink driving, on drugs of abuse. There is no curriculum within any education system that describes the importance of sleep. Where is that? I want to work with the World Health Organization. Let's develop one that is worldwide, across multiple countries, and then go into schools. The next one down is you've got to think about families. If you survey parents, 70% of parents who have teens believe their teen is getting sufficient sleep, yet only 11% of those teens are actually getting sufficient sleep. And yet we also have as parents, understandably so, I'm not judging, but we have this idea that they're sleeping in until the weekend. Number one, it's biological, their rhythms shift, it's not their choice. And second, at the weekend, they're sleeping off a debt that early school start times have lumbered them with. Yet we go in, we pull the curtains back and we say, you're wasting the day, get up. And then we have this parent-to-child transmission of sleep neglect. So in another 20 or 30 years' time, when they become parents, what do? They pull back the curtains, they say, you're wasting the day, and it repeats. And then you come to the individual level. And that's some of the stuff that we've been speaking about today. So that's one way that I would do it. In terms of science, gosh, we're doing a lot of work in aging and dementia. That's such a key thing. We've discovered that it's not simply an association between a lack of sleep and Alzheimer's disease, it's causal. And we know that evidence, and I can describe that too. That is so underfunded and so desperately in need of money. The other area is sleep and mental health. I will tell you that we have a large program here too. In the past 20 years, I have not been able to discover a single psychiatric condition in which sleep is normal. And I think that tells us everything about this relationship between sleep and mental health. How much work do we have in that area? There are some people in this department doing amazing work in that area, and we're trying to do some of that too, but it is utterly underfunded. The area of sleep and depression and anxiety, we've done work in there, but the area that is most sensitive to me, at least I think, is that of suicide. A lack of sleep is a canary in a coal mine. It predicts suicidal ideation, suicidal planning, suicidal attempts, and tragically, it predicts suicide completion. We need to fund that work too. So I could go on and on. I'm taking up too much time.
Yes. Thank you so much,
Thank you
Matt.
very much.
Yes, he's going to be hanging around. Yeah. We are going to switch gears a little bit. I know that, set a certain mood. It's important stuff to know. And my children will get yet another lecture when I get home today. But we're going to move now to our third speaker, Professor Dacher Keltner, who's a professor of psychology here in our department and also the director of the Greater Good Science Center. And he's going to talk to us today about the new science of awe, how everyday wonder can transform our lives.
Thanks so much for being here. Thanks for honoring our department. So wonderful to hear my colleagues speak. Every time I hear Matt's talk, I'm like, oh, my career is a probable carcinogen, But his book changed my life, and I find my pockets of sleep, so thank you. It is a very Berkeley idea, the study of awe, and it's great to share this latest science and this practice with you. Awe is the feeling of being in the presence of something vast and mysterious that challenges your current understanding of the world. And Celeste talk sort of hinted at the power of wonder in childhood, and requires that you seek integration and meaning. It's very interesting to me that humans, when we encounter vast mysteries, even horrifying ones, wonder about it, right? Our imaginations are activated. In our lab, we study many deep histories of awe. Awe traces back in the mammalian history to goosebumps or piloerection that you see in this rat showing. Social mammals really bind together, lean into each other when they face peril, just like humans do. Jane Goodall, one of my heroes, observed chimpanzees showing what she called a waterfall dance when they encountered really vast, mysterious things like waterfalls and storms and large gusts of wind, that led her to speculate that this was the beginning of mammalian spirituality, to be amazed at things outside of ourselves. Awe moves through culture, and as Einstein said, the fount of science and art. We've done a lot of work at Google Arts and Culture, tracking what it is, the perceptual qualities about art that make us feel awe and wonder. This is a Huicha Rica painting down in Mexico. Great traditions of awe in the indigenous traditions around the world. And awe has fueled science. If you read Darwin's Origin of the Species, it's all about awe and the wonders of nature, endless forms, most beautiful. These were drawings that inspired Darwin by von Heckel, who's a scientist, and he actually did 100 drawings of sea life about starting to kind of encapsulate the ideas of evolution that not only transformed science and Darwin, but also became kind of the visual motifs of Art Nouveau and all kinds of influences. The San Francisco World's Fair came out of drawings inspired by awe, really remarkably powerful emotion. What is awe? My students and I at Berkeley wondered about that, and given the great cultural diversity at this university, it's obviously, we've got to look at many different cultures. So we took a couple of years and we gathered stories in the spirit of William James. He wrote The Varieties of Religious Experience in 1912, where he really relied on stories to understand the mystical. We actually gathered stories from 26 different countries. Speakers of 20 languages here at UC Berkeley took about a year and a half to translate them. And what was striking is awe has this regular structure around the world. Comes from what I call 8 wonders. I'm going to talk about 2 tonight. From the moral beauty of people to nature to collective effervescence to, you know, if you are enjoying dance or the like, visual design, music, big ideas. I love Berkeley undergrads. We've surveyed Berkeley undergrads too, and they're full of big ideas, as you know, about chemistry and big data and Marxism and their favorite capitalism, right? As a big idea to challenge and to critique. And then mystical experience. And to our surprise, the life cycle. People are awestruck, very significant in our evolutionary history at the birth of young children. And we're also awestruck when life ends. It's a part of those themes. It is striking to read these stories because awe has this very deep individuality. I think each experience of awe is uniquely peculiar, if you will. And at the same time, you know right away what they're feeling when you read these stories from Brazil and Japan and China and India and Russia and the like. Some awe facts, if you will. And I, in doing the science for 15 years, 20 years, feel like if sleep is lesson 1 and teaching your children to learn and to question questionable facts, go find some awe. People feel it around the world a couple times a week. It's around us in really easily accessible ways. You don't have to hop on a plane, go to a retreat, et cetera. It deepens as you practice it. We did a study of the elderly doing awe walks once a week. Awe got deeper as they practiced it intentionally. It's around us. There are benefits. And I think most fundamentally, and I'll show you a little bit of data to this, and I think this is very relevant to the mental health crises of the day, it connects us to things that are larger than ourselves. That is foundational to our minds and to our social organization, is to connect to large systems. And that's what awe does, as we will see. I want to talk about 2 wonders of life that have surfaced in our data. The first is really striking when juxtaposed with what we see in digital platforms, which is that around the world, people are most moved to awe by the moral beauty of other people. That's what Immanuel Kant called it. Courage, kindness, overcoming obstacles. When you think about Mahatma Gandhi in a little room in Ahmedabad writing about nonviolence, those ideas going to the civil rights movement, those ideas going to the free speech protest at Berkeley, right, which led to anti-war protests, some of the first in the United States, along with the University of Michigan. That's awe-inspiring. The courage and kindness and overcoming of obstacles. In an experiment like this, what you do is you have people just settle into a moment of calm and reflection. And I encourage you just to take a moment and think about somebody whose courage and kindness and strength and resilience and overcoming moved you. I do this with my undergrads, so striking, just to think for a moment, right? And we measure different outcomes. For me, It's Serena Chan, my chair. She may be inspiring to you. I'm teasing my younger sister here at the college, but in our department, but very powerful exercise. When you just take a couple of minutes of awe in our lab and in other labs around the world, lots of work going on in Japan, Holland, and the like. The first thing that's really interesting is it activates this branch of your nervous system called the vagus nerve. It's the largest bundle of nerves in the mammalian nervous system. It goes from your top of your spinal cord into your gut, communicating with the flora and fauna of your gut, where 75% of your serotonin is. That is the mind-body nexus. It helps you orient to people, slows your heart rate, calms your body, associated with connecting. Awe activates that. Matt talked about the parts of the immune system. One of the really important foci in this research is the inflammation response. Heats up your body when pathogens are in your body, makes you feel sluggish and tired. When it's chronically activated, which is what poverty does, it is a pathway to every imaginable disease. It is bad news. And the only positive emotion that deactivates the inflammation response is awe. Lots of work in Korea, Japan, South Korea, and our lab showing that inflammation response is cooled. Second big wonder is a Berkeley idea, is nature. I hope you all know that the idea of the national parks hatched at UC Berkeley. It displaced indigenous peoples. We are ashamed of that, and we're correcting for that. The Institute of Parks is here at Berkeley. This past year, 360 million people went to national parks. It is an American experience. This is Ralph Waldo Emerson, great American transcendentalist, was on a cold day in this commons in Massachusetts, full of awe. In the woods, we return to reason and faith. There I feel that nothing can befall me in life, no disgrace, no calamity, which nature cannot repair. Standing on the bare ground, my head bathed by the blithe air and uplifted into infinite space, all mean egotism vanishes. When you teach Berkeley undergrads, it's very inspiring because they know the problems of our times are mean egotism, right? Too much self-focus, narcissism, consumption, and the like. And here's the idea that natural awe may actually shift us out of this hyper self-focused state. Here are a couple of quotes, very relevant historically. This is from first ascending Mont Blanc that unleashed backpacking and outdoors activity in Europe. The soul ascends, the vision of the spirit tends to expand. And in the midst of this majestic silence, one seems to hear the voice of nature become secret of its certain of its most secret operations. Lao Tzu, the Tao Te Ching, highest good, the life force is like water. It intersects with everything and doesn't contest. We get so much from nature, which is in real vulnerability, as you know. You can have people think about places of nature and find these benefits. We, in a study at UC Berkeley by Paul Piff, now a professor at UC Irvine. You guys remember that, the eucalyptus grove on campus? It's amazing, even though it's an invasive species. But we're working on that. The East Bay Regional Parks is culling a lot of the eucalyptus trees. Students looked up at the trees for a minute, or they looked up at a slightly less inspiring science building, which is probably where gene editing is taking place, right in there. And indeed, just a moment of awe in nature led students to feel less self-important, less entitled. They actually needed less money for the study. They're like, I don't believe in capitalism, man, you know. And we staged a little drama in the study, and somebody dropped some pens, and our students inspired to natural awe, helped out a stranger. Tons of research. Former Berkeley undergrad Francis Kuo is the leading scholar on how natural awe benefits the body. 15 different pathways. There are certain scents in nature, phytoncides that hit your skin and help your immune system. We are wired up to find awe and strength in nature. You know, as Serena said, part of what we do at Berkeley is get this knowledge out through the Greater Good Science Center. I'll just talk about a few things there. The motivation for that is really best expressed by the great writer Toni Morrison in a graduation speech she gave at Harvard Divinity School, I think, where she said, "Over time, these last 40 years, I've become more and more invested in making sure acts of goodness produce language. Allowing goodness its own speech does not annihilate evil. Awe is not, the panacea to all of our ills today. But it does allow me to signify my own understanding of goodness, the acquisition of self-knowledge." So at the Berkeley, first let me thank, it is a humbling privilege to work with Berkeley students. They are the best students in the world. There's nothing like them. These are just some of the people, many now professors, some of them first generation students becoming professors. But I was talking to our Dean of Undergraduate Education, Oliver O'Reilly, about one of our favorites from last year, second to the top on the left, Hari Srinivasan, non-speaking autistic, brilliant Soros fellow, did his research on awe in autism. It's much different than we would ever stereotype their experiences to be. He's now getting a PhD in neuroscience at Vanderbilt. So many remarkable people who are part of this. And then we're doing a lot of good stuff at the Greater Good Science Center. What I'm really excited about right now is returning awe into the classroom. And we have tens of thousands of teachers following our dissemination of allowing goodness its own speech. And we're going to be offering stuff for free to teachers who deserve lots of that. So thank you so much.
Thank you, Dacher. We have time for several questions. Questions out there?
Oh, there's one right there. Okay, hold on. Coming.
Yes. Earlier when you were showing that there was tests with trees versus buildings,
Yeah.
Was there a third part, or have you done studies with, I guess, the negative side of that, like with brutalist architecture or hostile architecture, to see if there was.
Are you thinking about our architecture building, for example? Worcester Hall, I know. Yeah, what a terrific question. And there's, first of all, we can talk about, there's a lot of awe design in architecture going on right now, which is cool. And it's a historic thing. It's always been part of it. But, the other, so we we've looked at dark awe, or like scary awe, horrifying awe in nature, in human activity, right? And it does have different properties than this kind of sort of expansive oceanic awe that I've been talking about. Your question also points to an important scientific issue, which is to pull apart awe from fear and horror and the kind of dreadful states that have long been of interest to philosophers. We've done that in a lot of different work that I'd love to bore you with, but I'll give you an in vivo demonstration. When I count to 3, I want you all to give me your best awe sound. No words, just a sound. 1, 2, 3.
Wow.
Doesn't sound anything like brutalist architecture, right? So it's a different space, and it's a great question.
Depending on the source of awe.
Yeah.
Negative version of awe.
Yeah. Yeah. They're,
The better the awe.
Yeah. Every human tendency can lead to problematic outcomes, right? The desire to celebrate, Halloween in South Korea led to 150 people getting crushed. Everything we do, dancing, right? Religion, etc. And the same is true of awe. About a quarter of the experiences of awe in different parts of the world have threat and terror embedded in it. You see a storm. I was backpacking with my daughter. We were at this peak in the Sierras, and an electrical storm just like came right over us, just hitting the ground. That was terrifying. And we were not in our most expansive of mindsets. And it's used to pernicious effect by, gurus and politicians and others. And there are always worries about our human nature.
We have another question here.
Hi, I'm over here behind the concrete,
Yeah.
You guys are making it tough on me, but that's okay.
realistic pillar over here. Hi. So I'm a graduate from the College of Letters and Science. So
Great.
thank you very much for allowing us to come. Students that are hearing me, the program works. Just keep at it. You'll be fine. I have a degree in Bones and Ashes from the University of California, Berkeley. I was a history major. My question is this. Is AI at a disadvantage because they can't feel awe?
Yeah.
Or at an advantage because they can't feel awe? Or how is that? How much do I have to worry at night? And while trying to get sleep, that the other doctor said. So please illuminate.
And by the way, making everybody here be sleep deprived for the next few weeks. So yeah, it's interesting. So we could talk about AI. We gathered 3,000 stories of awe around the world. No one mentioned technology. No one mentioned Google or Facebook or Meta. No one mentioned a smartphone. I think you're hamstrung in experiencing awe. Forgive me, I think virtual reality is a joke. So it's good for games, but not for awe. You need to be around people in the flesh and around real nature. AI is a whole different question. Can it feel? No. Feeling is about life. It's about purpose and the animating force of living forms. AI can simulate certain things, and it can be smart and ethical. And I think that it will. I think there are certain places in the AI digital space where we have pathways to awe, like the music we can hear around the world, and that'll be interesting to see what AI develops. So, good question.
Maybe one more question before we move on. Is there anything out there? Right here?
Oh, here you go.
Oh, okay.
Oh, okay.
Hey, Art.
Was there someone else who wanted to?
There was someone else, Art, if that's okay. Yeah. I know Art, so yeah.
I was just wondering, out of the 8 wonders that you mentioned,
Yeah.
what exactly do you mean by collective effervescence, and how did you see that manifested in the stories?
Oh my God. Well, we've got our athletic director of collective effervescence over there, Jim Knowlton. Thank you for coming. Collective effervescence is this profoundly important human capacity, begins very early in life, to synchronize with other people and to fold into shared movement. We are really different from a lot of primates in our capacity to do that. It begins early, and it's foundational, as Emil Durkheim argued, to religious ceremony, to dance, and we should all be dancing more. And in the book, it was fun to review the literature on sports, how meaningful sports are, because we get together, we share joys, we move together, we have ideas about who we are in our identity. So it's this shared movement and the remarkable ecstatic bubbling feeling that you feel. Have you ever felt that?
Yeah.
There you go.
Yeah.
So thanks for asking. Yeah. It's a whole new area of science. It required a whole different kind of statistics. You got to measure multiple people at the same time, and we're learning a lot about it, which is really neat. Great question.
Great. Thank you, Dacher. Okay. Thank you to all 3 speakers. We're going to shift now to the final 2 presentations of our program tonight, short demonstrations. We're going to start with Rich Ivory, who's a distinguished professor of psychology and neuroscience, and he's going to show us one of the tools he uses in his research, transcranial magnetic stimulation. Did I get that right? Yes, and I'm in the way. Okay. Yeah, use it. Yeah.
Maybe Dacher, the pickleball craze is people seeking awe now in community or something. So I'm one of the members of the cognitive neuroscience group here, and we're always looking for tools to usually measure the brain, like things like MRI, fMRI, EEG, and so forth. But as experimentalists, that's usually very useful for correlating physiological changes with behavior. But we also want to test ideas by being able to actually manipulate things. And that's where non-invasive brain stimulation comes along. And Carolyn Irving, one of our stellar post-bac graduates here. It's going to do a demonstration. This is a device called a transcranial magnetic stimulation. It was developed around 1980 for clinical purposes to map out the motor pathways. We had EEG to measure how sensory signals were being recorded by the brain, but how did we look at the output? And this device was done for it. I'm going to be the demonstration guinea pig here. And I'm going to hold up my arm here, and Carolyn has had a lot of training at this, and I'm betting within 1 or 2 shots, she's going to be able to find my motor cortex. Right. So let's see if that works here. Okay. So you can probably see, okay, very brisk movement there. I'm not doing this on my own. She's the puppeteer here. She basically can make me make any sort of movement. She can move the device around and probably get a different part to, let's see, there's move towards my fingers from the hand there. And maybe try a little bit in the front there and see what we get. And you might have seen there, we got a blink.
You're a little too tall for me.
A little too tall. Thank you, Carolyn. So there was a trick there, actually. At the end, when she moved it forward, you might have thought maybe she's now making my facial muscles move. But if you've been paying attention, you would have seen that actually the blink was on the right side of my body. And that's because she's basically hitting the cranial nerve directly. The other part, though, is transcranial, where she's going through my skull and activating the motor cortex. Now, again, that was initially developed as a method for neurologists to assess motor function. But quickly, people have recognized that if we can perturb brain function or artificially stimulate the brain, that there might be both research applications, something that I do, about asking if I perturb a particular part of the brain, can I induce certain changes in behavior to test theories and so forth. But there's been great interest about how might this have translational value. And this system here, the transcranial magnetic stimulation, was approved in 2009 by the FDA as a treatment for depression. It's always used after people drug-resistant forms of depression. Again, in a future world, maybe roles will reverse. People recognize that medications really aren't that effective, and maybe we'll be looking for, non-invasive stimulation techniques as a first course of intervention. Now, this is a device that is doing a very short pulse because it's generating a magnetic field that's going to pass through the skull. The advantage of that is that I don't feel anything. I don't have any magnetic sensors in the skull. Matt already mentioned, though, that there's other ways to do this, electrical stimulation. He described how that's being used for sleep. The trouble with electrical stimulation is we get a shock. If you turn that current up, it's going to become very unpleasant very quickly. And so there's a limitation there that you can't give a very intense treatment with the electrical methods. And so one of the great things about being at Berkeley is that there's such strength across all the different fields. And I've been fortunate enough that we were talking about some of our work and kind of complaining about the electrical methods not being strong enough. And we ended up collaborating with some physicists at our brain imaging center who said, well, the trick is instead of running this through a capacitor, run it through an amplifier. Okay, and if you use through an amplifier, it's still magnetic stimulation. So you're not going to have any of that adverse effect of the stimulation, but you can actually induce a much stronger effect on the brain. Of course, all staying within safe limits. And so again, this is in the very early stages, but it's a really nice example about the power of Berkeley, about this interdisciplinary, cross-fertilization there, where these folks just came up and said, well, here's a different way to drive things. And hopefully this is going to develop new methods of non-invasive brain stimulation that can achieve the same sorts of things that Matt was talking about, but also with a much stronger stimulation so that we could control things, give sort of dose-dependent or dose-tailored responses. So again, early stages, but a very exciting venture to be part of. Thank you.
Thank you so much, Rich. And Rich will be around if you have questions. So last but not least, we're going to welcome Celeste Kidd back to the front with a special guest, Miro. And Celeste is going to show us another tool that researchers in many different areas of psychology use. She mentioned it in her talk, eye tracking. Here. Yeah, yeah, awesome.
Yeah, so we're going to show our head-mounted system. This is a system that we can use with infants as soon as they can hold up their own heads. We don't use, as like today with Miro, we're using the glasses because he's got a bigger head than a little baby. But I'm just going to show you guys the basics of how it works. We also have Sarah Stolp, that's a very talented graduate student in the lab, who's brought a different type of eye tracker that is monitor-based that she's using to study the relationship between engagement and learning, testing the idea that like more looking isn't necessarily more learning. So this system is the positive science system, and how it works is there are two cameras. We have one camera here that is capturing a subset of everything that he can see. It is not the whole visual field, so we have to orient it and select what we want to be looking at. There's a second camera right here that is capturing an image of his eye. And Holly is going to show you guys on the monitor and turn it around so you can see both of those cameras. The way that it works is this camera that's capturing his eye, this stalk also has a fixed light source on it that creates a reflection on his cornea. We have special software that is written to look at the relationship between the pupil in the image and the corneal reflection. Eyes are not totally spherical. So as the eye moves around, the relationship between that light reflection and the pupil changes. And if we calibrate it, then we're able to tell where in the visual scene Miro or anybody that we put this on is looking at. Miro, do you want to demonstrate how we do the calibration? Maybe, yeah, okay. I was going to use my phone, but then I realized that I didn't give you an after-school snack, so I thought of something much better. When we do this with babies, the challenge is that they don't understand words. So you can try to give them instructions, but they will not understand you. So calibrating with a baby, we have to do it all non-verbally. And one of the methods that we've used is by holding out like little pieces of food that they like. Mira, I'm going to ask you to hold your head steady and then just look at this, okay? And then if you look, and maybe Holly, you could like turn the monitor so everybody can see. What we do to calibrate it is try to sample different parts of the visual field. If it's food, you can be pretty sure that that is what a baby is looking at. So we try to hold it in different points of the subset of the visual field that we're capturing. And then we go in after the fact and then show, I was like, click it in order to calibrate it. And that's how we tell where in the scene he's looking. And that's how we superimpose that purple dot on top of the scene after the fact. Do you want to eat this? Yeah, cool. Thank you. Is it comfy? It's okay? Cool. Miro is the youngest member of our lab. He tests out a lot of our experiments, and I'm very grateful. So on that note, if you'd like to stop by and see Sarah and the monitor-based eye tracker, we have that set up over here. So thanks.
Thank you, Celeste, and thank you, Miro. Now you can have more treats. Okay, we're going to close tonight with some remarks from Christian Gordon, who I want to thank him and his team for putting this event together. Christian is the Assistant Dean of Development for the Social Sciences Division.
Thank you, Serena. I want to thank all of our faculty presenters, but can we give it up for Miro one last time? Kid's a star. So thank you again to all of our faculty presentations, and thank you to all of you for being here. For a little over 7 years, I've had the honor and the privilege of serving as the Assistant Dean of Development for Social Sciences at UC Berkeley while we have undertaken the Light the Way campaign. I'm very pleased and proud to say that the university and the Division of Social Sciences and Berkeley Psychology will be successful in that campaign, which will reset the foundation of support and our abilities into the future as we think about it tonight, the next 100 years of Berkeley Psychology. This is also a transference of agency, of ownership and support from the state of California to the stakeholders of the institution, our alumni, our friends, and our philanthropic partners. So I want to thank all of you. This room is filled with and joined by people around the world who have made investments and sacrifices to improve the conditions and the opportunities of our faculty and students. So thank you for everything that you've done to make that a success. This success allows us to think about where do we want to go from here? Where do we want to go from this foundation? In the social sciences and Berkeley Psychology, it is a threefold mission: research, community, and successful student outcomes. There are many ways to support this. We got a great glimpse into the research component tonight. And I want to shift, as we end, the attention a little bit from the faculty to the engine that drives research at UC Berkeley. If you are a psychology graduate student, could you raise your hand, please? These are the hardest working people at the institution. They teach, they support research and faculty, they're critical to faculty recruitment and retention. And we're incredibly grateful for their efforts here in Berkeley Psychology, particularly where we have enjoyed the support to help craft our campaign, to craft our messaging. So I want to thank Juliana Chase, Ashley Halkett, and others who already overworked have given their time and energy to help this campaign be successful. So thank you for all that you do. This is also an opportunity to celebrate our heroes as we complete this campaign and look ahead to the next century. And I'd like to end by recognizing and thanking some people who have made a transformational gift to support graduate students into the future. When those who know you best invest in you, it sends a very powerful message. And when our faculty chooses to support us with their philanthropy, it's much bigger than just a financial gift. It's a powerful signal and investment in our community. And I want to thank Professor Bob Knight and his partner Donatella Scabini for making an incredibly generous planned gift to support graduate students in psychology and neuroscience. Bob, thank you. For over 2 decades, Bob has been a leading faculty member in Berkeley Psychology, an award-winning researcher, teacher, mentor, and I'm very grateful for him and Donatella, who will now extend their legacy of support far into the future with this gift that will support graduate students in perpetuity. So thank you, Bob and Donatella. Thank you to all of you for your contributions, of intellectual contributions, philanthropic contributions, and I look forward to our partnership into the future. Thank you, and enjoy the rest of your evening.
The bar will be open a little longer. Feel free to mingle. We have some faculty and graduate students around to chat if you're interested, and the speakers are still around if you have more questions that weren't answered. Thank you all so much for coming.